Mastering Arithmetic Progressions, the Power of Patterns. Today's lesson is about arithmetic progressions, one of the most interesting and useful topics in mathematics. Have you noticed patterns in staircases, calendars, seating arrangements, or savings plans? Many of these follow a simple mathematical rule called an arithmetic progression, or AP. In this lesson, we'll learn how to identify an AP, find any term in the sequence, calculate the sum of many terms, and discover how arithmetic progressions are used in everyday life. Let's begin. What is an arithmetic progression? An arithmetic progression, or AP, is a sequence of numbers in which the difference between consecutive terms is always the same. This constant difference is called the common difference, represented by the letter D. For example, 5, 7, 9, 11, 13. Each term increases by 2. Since the difference remains constant, this is an arithmetic progression. Whenever the difference between consecutive terms is constant, the sequence is an AP. Identifying the pattern. Not every arithmetic progression increases. If the common difference is positive, the numbers keep increasing. For example, 3, 6, 9, 12. If the common difference is negative, the numbers decrease. For example, 10, 7, 4, 1. If the common difference is 0, every term remains the same. For example, 5, 5, 5, 5. A quick way to check whether a sequence is an AP is to subtract one term from the next. If the difference is always the same, you've found an arithmetic progression. The anatomy of an AP. Every arithmetic progression is completely described by just 3 values. The first term, represented by A, tells us where the sequence begins. The position, represented by N, tells us which term we want to find. The common difference, represented by D, tells us how much is added or subtracted each time. Using these 3 values, we can generate every term in the sequence. Finding any term. Instead of writing every term one by one, we can directly calculate any term using the nth term formula. The formula is a sub n equals a plus open bracket n minus 1 close bracket multiplied by D. Let's consider the sequence. 2, 6, 10, 14. Here, the first term is 2. The common difference is 4. To find the 12th term, substitute the values into the formula. The answer is 46. This formula saves both time and effort. Arithmetic means. Sometimes we need to insert numbers between 2 given values so that the sequence remains an arithmetic progression. These inserted numbers are called arithmetic means. Suppose we want to insert 3 arithmetic means between 28 and 42. First determine how many total terms are present. Then calculate the common difference. Finally, fill the missing numbers using equal intervals. The completed sequence becomes 28, 31.5, 35, 38.5, 42. Notice that every pair of consecutive terms differs by the same amount. Arithmetic series. So far we've discussed a sequence, which is simply a list of numbers. Now let's talk about a series. A series is the sum of those numbers. For example, the sequence is 1, 3, 5, 7, 9. The series is 1 plus 3 plus 5 plus 7 plus 9, which equals 25. The symbol S sub n represents the sum of the first n terms. Sum of an arithmetic series. The formula for finding the sum of an arithmetic series was popularized by the great mathematician Carl Friedrich Gauss. The formula is S sub n equals n divided by 2 multiplied by open bracket first term plus last term close bracket. Instead of adding hundreds of numbers one by one, this formula gives the answer instantly. It is one of the most useful formulas in mathematics. Worked example. Let's solve an example. The sequence begins with minus 10, minus 9.75, minus 9.5, and continues with a common difference of 0.25. To find the 75th term, use the nth term formula. The answer is 8.5. Now apply the sum formula. The sum of the first 75 terms is minus 56.25. This example shows that arithmetic progression formulas work perfectly even with negative numbers and decimals. Real-life applications. Arithmetic progressions appear in many real-life situations. Banks use them to calculate regular savings. Computer programmers use them in algorithms. Engineers apply them in design and measurement. Physicists use them to describe uniform motion. Even arranging chairs in an auditorium often follows an arithmetic progression. Once you understand the pattern, you can predict future values quickly and accurately. Let's summarize today's lesson. We learned what an arithmetic progression is. We understood the meaning of the first term, common difference, and position. We used the nth term formula to find any term directly. We learned how to insert arithmetic means. We distinguished between a sequence and a series. Finally, we studied the sum formula and solved practical examples. Arithmetic progressions help us understand patterns, make predictions, and solve many real-world problems in mathematics, science, engineering, finance, and computer science. Thank you for learning.